Good morning to one and all present here. Today class discuss about the unit 4 model 1 lecture 3. Shall I now discuss about the topic Compton effect and physical significance of wave function. Okay, next Compton effect. When a beam of monochromatic radiation such as X-rays, gamma rays, electron beam, neutron beam, monochromatic source of light source, sodium vapor lamp, mercury vapor lamp, etc. This light beam's high frequency is allowed to fall a fine scattered. This frequency of light beams incident on this electron after that scattered these beams. The beam is scattered into two components. One component having the same frequency or same wavelength, that is the incident radiation. Okay, but this principle for unmodified radiation. This process is called unmodified radiation. That is phi equal to 0 degree or theta equal to 0 degree angle. But this is same frequency, same wavelength of the incident radiation. Okay, this Compton effect, this relation for collision between electron and photon. The other component having the lower frequency or higher wavelength compared to incident radiation, where frequency and wavelength is reciprocally. According to de Broglie wavelength, lambda equal to h by p, p for mv. Okay, and then nu for c by lambda, c by lambda. Okay, this is lambda equal to nu by c, lambda equal to nu by c. And then we have to this analyze with this modified radiation. Your incident radiation depending, your beams are scattered. There are two components. First one is unmodified radiation analysis, second one is modified radiation. This in between gap, in between range, there is change in wavelength. This are for unmodified radiation, consider this lambda. Modified radiation lambda dash. This difference between the wavelength is called Compton shift or Compton wavelength. This effect is known as Compton effect. And next, Compton shift define when a photon of energy h nu, then this energy collides with an electron of a scattered at rest. Okay, electron rest position here, we got to apply the photon energy. The photon energy absorbed this electron, after that for these are emitted, these are scattered these photons. The photon gives its energy to the electron, but the scattered photon will have the lesser energy or lower frequency. The frequency is low, that is higher wavelength, is compared to the wavelength of the incident photon energy. Since the electron gains energy, okay, so one component for scattered the photon energy and another component for recoils of the electron. This returns to the electrons with respect to the velocity p equal to mv, as in the velocity momentum of the particles. This effect is called Compton effect. The shift in wavelength is called Compton shift. The theory of Compton effect principle. In Compton scattering, the collision between a photon and an electron considered. Then by applying the law of conservation of energy and law of conservation of momentum, the expression for Compton wavelength is derived. The collision occurs between the photon and the electron in the scattered material. When the electron is free, which time the electrons are for absence of electric field or rest positions of the electrons and photons, but these electrons are freely moving. These are before collision. This is a rest position of the electron. So these are freely moving in the atoms or molecules with the incident photons. Okay, you got the electron and photon energy incident after the electrons first scattered. Figure shows this. This for incident photon energy E equal to h nu. This momentum P equal to h nu by c. This are electron, this center midpoint electron, this are x component, this are x component, this are y component. The photon energy incident after two components are producing. So one for scattered, other one for recoil electron producing. This recoil electron for E equal to mc squared. Scattered photon energy E equal to h nu dash. The momentum equal to h nu dash by c. Okay, this incident photon, these are before collision. After collision, scattered energy and recoil electron. Electron at rest position E equal to m naught c squared. These are Einstein mass energy relation. These are E equal to m naught c squared. Before and after collision, x component and y component analyzed. Before and after collision, x and y component momentum of the collisions analyzed. And next figure shows the incident photon energy, the momentum for P equal to h nu by c. This graph is platted. This is scattered photon recoil electron. This is joining this for triangular waveforms OAB and OBC. This is scattered photon. This is recoil electron. This angle for x component angle for theta, this is x component recoil electron 5. Okay, this y component for my and the negative axis minus my. The momentum P equal to mv. And x component momentum mx, y component momentum my. This angle is for theta. This angle for similarly opposite side theta, and this angle is 5. This is cos theta. Both for cos theta. This is cos theta, sin theta. This is cos phi, sin phi. You have to derive this before and after collision process. Energy before collision. The energy of the incident photon. Energy of the incident photon. You have to apply this graph. Incident photon h nu. Energy of the electron at rest m naught c squared. Total energy before collision equal to h nu plus m naught c squared. You see this figure. E equal to h nu, this is energy, incident photon, okay, incident photon energy, incident electron at rest, E equal to m naught c squared, okay, total energy before collision equal to h nu plus m naught c squared. After collision, this energy instant after scattered and recoil electron. Okay, but this is second after collision, scattered photon h nu dash changes. This energy of the recoil electron mc squared. mc squared. Okay, this after collision energy equal to h nu dash plus mc squared. You have to added both h nu dash plus mc squared. That is equation 1 and 2 consider. This is both for equating. You go to the law of according to law of conservation of energy. The total energy before collision equal to total energy after collision. This equating 1 and 2. H nu plus m naught c squared equal to h nu dash plus mc squared. For x component of momentum before collision, x component of momentum of the incident photon mx equal to h nu by c, x component of momentum of the electron at rest equal to 0. This total x component of momentum before collision equal to h nu by c. Figure shows the this is the momentum of the diagram. This was x component. This was P equal to h nu by c momentum. Okay, this is for momentum for this electron at rest equal to. But this for electron for not moving. 0 velocity 0. Electron at rest equal to 0. But before collision only h nu by c. After collision h nu dash by c and mx. Okay, you can triangular OAB cos theta equal to triangular OAB cos theta equal to h nu dash mx. Mx divided by h nu dash by c. But therefore mx equal to h nu dash by c into cos theta. But similarly recoil electron mv. This mv. Okay, and mx by me equal to cos phi. Mx equal to me into cos phi. That is after collision. you see this x component of momentum after collision, x component of momentum scattered of the photon, this for h nu dash cos theta by c, x component of the recoil electron mv cos phi. Therefore cos theta equal to mx by h nu dash by c and cos phi equal to mx by mv. But therefore total x component of momentum after collision equal to h nu dash cos theta by c plus mv cos phi. That is equation number 5. According to law of conservation of momentum, total momentum before collision equal to total momentum after collision. Equating 4 and 5. Getting 4 and 5. And then next, y component of the momentum of the incident photon, y component direction எந்த ஒரு incident of photon energy apply பண்ணலாம். That is 0. Y component of momentum electron at rest equal to 0. Y component of the momentum before collision equal to 0. And therefore y component of momentum after collision, that is for my direction. This my equal to h nu dash sin theta by c. Y component of the recoil electron minus mv sin phi. The total y component of the momentum after collision equal to h nu dash sin theta by c minus mv sin phi. Okay, you see this figure. Identify the y component of momentum after collision. This for my before collision is 0. After collision, this is scattered photon one component, other component recoil electron. This for OAE sin theta equal to mx by h nu dash by c by my equal to h nu dash by c sin theta. This one minus my recoil electron p equal to mv. This for sin phi. Okay, sin phi equal to minus mv. Okay, sin phi equal to minus my by mv. Therefore my equal to minus mv sin phi. This is a triangular OCD. This are after collision for the y component. Okay, this equation number you have to consider the 8. Both are added. My direction scattered photon, my direction for recoil electron, h nu dash sin theta by c minus mv sin phi. According to law of conservation of momentum, equating 7 and 8, 0 equal to, okay, before collision 0 equal to h nu dash sin theta by c minus mv sin phi. You have to substitute this equation number. Okay, equation number 6. Equation number 6. H nu by c minus h nu dash by c cos theta equal to mv cos phi. Okay, but this for the common term h take it nu minus nu dash cos theta. So both we have to multiply by c m cv cos phi. This is right hand side c multiplied mcv cos phi. Okay, left hand side c for cancel it. 2 terms c cancel it. Remaining term for h common term take it nu minus nu dash cos theta. Go to simplify this equation number 6. And then equation number, okay, next for equation number 9 take it. Equation number 9. You go to simplify. You go to multiply it by c. Simplify this equation. C cancel. H nu dash sin theta. Okay, h nu dash sin theta equal to mcv sin phi. mcv sin phi. Equation 9 and 6 line you can to simplify this equation. This equation cancel 10 and 11. Okay, this equation 10 and 11 squaring and adding. You go to squaring this equation. Okay, first you take it m squared c squared v squared left hand side both for, okay, m squared c squared v squared for common term multiplied this two equation and remaining term cos squared phi plus sin squared phi, that is equal to this for h into nu minus nu dash cos theta whole square. So a minus b whole squared formula h squared into a squared minus 2 nu dash cos theta plus nu dash squared into cos squared theta plus this 11th equation squaring h squared nu dash squared sin squared theta. Again you have to simplify this equation. Cos squared phi plus sin squared phi for 1, cos squared phi and sin squared phi for 1. For this term you go to simplify 1 consider, and then h squared common term take it and nu dash squared take it, and remaining term cos squared theta and then sin squared theta, these are plus consider. This term la common term you take it h squared nu dash squared cos squared theta, okay va, and then this is sin squared theta, this was sin squared theta, okay va. This for commonly bracket take it h squared nu dash squared, that is equal to this are 1 consider h squared nu dash squared. Okay, again you have to substitute this equation. This for remaining term take it, this for 1 remaining term m squared c squared v squared equal to h squared bracket now nu squared minus 2 nu dash cos theta plus h squared nu dash squared sin squared theta தான் நம்ம வந்து யூஸ் பண்ணி ஒன்றுன்னு கொண்டு வந்துட்டோமா. அப்போ இங்கே ரிமைனிங் டேர்ம்ஸ் என்ன நம்ம யூஸ் பண்ணது h squared nu dash squared only. இப்போ this h squared commonly take it, remaining term nu dash squared, remaining term nu dash squared, okay va. This for this h squared nu dash squared, h squared for take it and remaining nu dash squared. Okay, from equation 3 we can write. Okay, equation 3 லேருந்து நம்ம calculate பண்ணி energy before collision after collision. You have to simplify this equation. mc squared equal to m naught c squared plus h into nu minus nu dash, okay va. But this are equating 1 and 2 லேருந்து third equation proof பண்ணது you have to consider. h nu m naught c squared equal to h nu dash mc. இப்போ இதிலேருந்து mc squared equal to h common nu minus nu dash, okay va, and m naught c squared. Okay, mc squared equal to m naught c squared plus h nu minus nu dash. So squaring on both sides. mc squared square பண்ணா m squared c power 4 equal to m naught squared c power 4 plus this for a squared plus a plus b whole squared formula by a squared for m naught squared c power 4 plus 2ab க்கு 2 m naught squared m naught c squared h into nu minus nu dash plus b squared h squared into nu squared minus 2 nu dash plus nu dash squared, okay va. This for equation considered 13. This 13 equation subtracted to the 12th equation. We simplified this equation, okay va. So m squared c to the 4, அதில் m squared c squared இருக்குது. Commonly you take m squared c squared. The remaining terms for 13 equation c squared here, and 12th equation v squared extra left hand side இருக்குது c squared minus v squared, that is equal to, okay va, m naught squared c to the 4 here you go to return m naught squared c to the 4 plus 2h m naught c squared into nu minus nu dash you go to return, and then these are 12 equation la h squared nu squared, idhe h squared nu squared cancel it, and then next for adile h squared nu dash squared, idile h squared nu dash squared cancel it, plus minus cancel. Remaining term enna h squared idile common adile common minus 2 nu dash minus 2 nu dash you go to commonly take it, minus 2 h squared nu dash take it. These are 1 13 to 12 1 times 1 minus here cos theta, 1 minus cos theta, okay va. So you go to consider the 14th equation. Next, according to general theory of relativity, the variation of mass m, this is mass of an velocity v, and then velocity of light is c, and rest mass of electron m naught. This is then general theory of relativity equation m equal to m naught divided by root of 1 minus v squared by c squared. This equation squaring on both sides, m squared equal to m naught squared divided by 1 minus c squared by c squared. Again simplify this equation. So LCM take it, c squared minus v squared by c squared, and then going to numerator m naught squared c squared divided by c squared minus v squared. This is a cross product, m squared into c squared minus v squared equal to m naught squared c squared. Okay, va? This equation, consider 15. This 15 equation you go to multiply by c squared on both sides. M squared c squared into c squared minus v squared equal to m naught squared c to the power 4. This equation you go to multiply by c squared. Both sides multiplied. M squared c squared into c squared minus v squared equal to m naught squared c to the power 4. This equation number 16. This equation number 16 and 14 equating, we can write 14 and 16 equation equating. Why? Both the side for you have to simplify. M naught squared is to the power 4. Okay, va? 16th equation m naught squared is to the power 4 here. 14th equation, okay, va? M squared c squared minus c m naught squared is to the power 4 here. M naught squared is to the power 4 plus 2h m naught c squared into nu minus nu dash minus 2h squared nu dash into 1 minus cos theta. We have to simplify this term. M naught c to the power 4. We have to substitute this term. Okay, this remaining term you have to substitute. This m squared c squared means v squared. 14th equation m naught squared c to the power 4 equal to m naught squared c to the power 4 plus 2h m naught c squared into nu minus nu dash minus 2h squared nu dash 1 minus cos theta. The equation 16 14 equation la substitute பண்ணி equate பண்றோம். Okay va? But that is this for simplified this term m naught squared c to the power 4 m naught squared cancel and plus minus, and remaining term 2h m naught, remaining term 2h m naught c squared nu minus nu dash இது அப்படியே இங்க எடுத்து எழுதிக்கிறீங்க இது அப்படியே, and that is equal to minus this side coming plus minus this side coming plus 2h squared nu dash into 1 minus cos theta. Okay va? And then next common term, constant term outside take it. This are changing this frequency only, take it nu minus nu dash divided by okay, nu dash equal to okay, 2h m naught c squared, go to the denominator right hand side, h cancel, 1h here, 2 cancel. Okay va? And then m naught c squared here in denominator, h divided by m naught c squared into 1 minus cos theta. And separate this equation of the frequency, nu divided by nu dash minus nu dash divided by nu dash equal to h by m naught c squared into 1 minus cos theta. Okay, 1 by nu dash minus 1 by nu, that is equal to h divided by m naught c squared into 1 minus cos theta. Multiply both sides by c, we get c by, how to consider c, multiply on both sides. Okay, அதில் nu cancel, remaining 1 by nu dash equal to multiplied by c by nu dash minus so nu dash cancel, 1 by nu, c by nu equal to hc divided by m naught c squared into 1 minus cos theta. Why ma'am we go to c multiplied. Okay, lambda equal to c by nu equal to c by lambda, அப்போ lambda equal to c by nu. You go to simplify this term, c by nu dash lambda dash c by nu lambda. Okay, c cancel, right hand side only h by m naught c into 1 minus cos theta. Lambda dash minus lambda equal to h by m naught c into 1 minus cos theta. But therefore change in wavelength equal to change in wavelength delta lambda equal to h by m naught c into 1 minus cos theta. This for standard equation for Compton scattering effect equation. Change in wavelength, h Planck's constant 6.624 in 10 power minus 34, m naught rest mass of an electron 9.11 into 10 power minus 31 kilogram per mole, c velocity of light 3 into 10 power plus 8 meter per second, and then you go to scattering of the photon energy, this angle changes theta 0 degree, 45 degree, 90 degree, 125 degree. Okay, this is experimental method. This is a Compton effect. sorry, X-rays passing in the zinc crystalline material. This crystalline material angle is varied. This incident after for scattered this X-ray beams. The X-rays angles analyzed. Okay, this is spectrum for analyzed. Okay, modified and unmodified line and change in wavelength for analyzed. Lambda lambda dash, that is delta lambda or d lambda. Lambda or d lambda. Your cos theta angle depending this modified and unmodified lines are analyzed. Okay, unmodified line meaning same frequency, same wavelength occurs. And then modified line, you go to incident photon energy for lower frequency or higher wavelength, or higher frequency, lower wavelength. You go to applied incident radiation depending. After that, one component for scatter, another component for recoil electron. Next, some special cases occur. This equation number 18th. This theta equal to 0 degree, cos theta equal to 1, cos 0 1. Now 1 minus, we go to substitute this delta lambda, cos theta 1, 1 minus 1, 0, 0 multiplied into h by naught is 0, but that is delta lambda equal to 0. This for unmodified radiations. But there is absence of scattering. Theta equal to 90 degree, cos theta equal to cos 90 for 0. So cos 90 is 0, 1 minus 0, 1 into h by m naught c. You got to substitute this constant value. You got to change in wavelength, delta lambda 0.024. 424 Armstrong or 10 power minus 10 meter. And then third case is theta equal to 180 degree, cos pi equal to minus 1. Delta lambda equal to h by m naught c into 1 minus of minus 1. 1 plus 1, 2 h by m naught c, 2 times of h by m naught c value. Already h by m naught c multiplied 0.0224 and then multiplied 2 for 0.4848 Armstrong. Okay, this 180 degree, this is shifting wavelength, this is a modified line analyzed. Worth changing this angle theta and then 5 varies 0 to 180 degree. The change in shift value analyzed, lambda and lambda plus 2h by m naught c. Okay, students. Thank you, students. Thank you, one and all.